Hello everyone, welcome to BioWise with Aanchal. Now, as per the request from the students, instead of starting with chapter 3, I am doing chapter 4 after chapter 2. That is, after physical and chemical change, the third chapter is element, compound, and mixture, that I will be covering after the atomic structure. Okay, so let us begin. Before I begin, I request everyone, those who have not subscribed the channel and still watching the video, you are requested to subscribe, and let's move ahead with the atomic structure. In this chapter, we are going to study about the structure of an atom, ancient views on atomic structure, subatomic particles, discovery of electrons, discovery of protons, discovery of atomic nucleus, discovery of neutrons, Bohr's atomic theory, followed by periodic table, groups, periods, atomic number, mass number, atomic weight, that is relative atomic mass, molecular mass, electronic configuration, isotopes, formation of compounds from atoms. Moving to next, we'll talk about the structure of the atom. Before going into the structure of the atom, we must know about the ancient views of the atomic structure. The word atom is a Greek word and it means indivisible. We know that now atom cannot be indivisible because we have to study about the subatomic particles, that is electron, protons and neutrons. We have already covered this topic in standard 7. So I'll be just going through the topics. In case you have any doubt, put it in the comment section. Okay, now next, Kannada, that is Maharishi Kannada, he gave us a concept that matter is made up of particles called Paramanus. So he has called the atoms as Paramanus, and he also talked about the atomic compounds. According to him, the binary atomic compound, that is compounds made up of two atoms, he called it Adavyanuka, and even the combinations of further, that is 2 or 3 or more atoms, he gave the term as Trayanuka, that is Tranuka. Okay, so these are not very important for your exam, but we must know about the history when we study about any topic. Okay, this is the history of atomic structure. That is, Dalton in 1808, he first described the atoms in the modern scientific sense. He gave the idea of atoms, but he could not explain the electricity or the why the atoms are electrically neutral. These concepts could not be explained by Dalton. Next, we move to Thomson, that is in the year 1897. He gave the concept of plum pudding model. Now, according to him, he explained that electrons are nothing but the raisins in a kheer, or you can say in a pudding. So he could not explain the presence or distribution of the subatomic particles in the atom. Therefore, his theory was discarded. Then, that is moving ahead, in the year 1911, Rutherford, he discovered the nucleus by his famous alpha particle experiment on the gold foil, but he could not explain the concept that why electrons do not lose energy and crash into the nucleus. You all know that any negative particle which is moving around a positive center has a possibility that the negative component may fall into the nucleus, but Rutherford could not explain. Now this is still a question, that why the electrons do not fall in the nucleus. This is your question, children. Write it in the comment section. Now, in the year 1913, Bohr gave a modern atomic theory, and he explained about the orbits and the electron shells and the distribution of electrons around the nucleus. In 1926, finally the quantum mechanics were explained, where shells are actually considered as orbitals. Those who are going to take science and study in 11th and 12th, you will surely study about orbitals. We are not going into the details of the orbitals in your 8th, 9th and 10th standard. Chadwick in 1932, he discovered neutrons. So after all this, later on in the year 1932, the neutrons were discovered. So this is just a timeline to show how the progress happened in the field of atomic structure. Moving to the next, that is Dalton's theory. He formulated the modern version of the atomic theory, and in his model all the atoms in a given chemical were exactly alike, while the atoms of different elements were different. This is so obvious, like atoms of oxygen, if you consider oxygen atom, if you consider hydrogen atom, if you consider nitrogen atom. So according to him, all the atoms in a given chemical were alike, while the atoms of different elements were different. So oxygen will have all the atoms of oxygen as oxygen atom, right? So he gave certain, um, he explained successfully a number of chemical observations, such as law of chemical combination, but he failed to explain the difference shown by elements towards the different chemical activities. So let us move ahead with the main postulates of Dalton's theory. According to Dalton, matter consists of small particles called atoms. Atoms are indivisible and cannot be created or destroyed. Atoms of the same element are alike but differ from atoms of the other element. Compounds or molecules are formed when atoms combine with the other atoms in a simple whole number ratios. An atom is the smallest unit of matter which takes part in a chemical reaction. So according to him, these postulates, if you remember, generally the questions are not very direct, but you should know about what Dalton's theory is all about. Then there are some contradictions of the theories. Dalton theory said that the atoms are indestructible. That is, you cannot, it's indivisible matter. But according to the modern atomic theory, atoms are destructible. They can be broken down into simple subatomic particles. An atom is the indivisible smallest particle of an element according to Dalton's theory, but atoms are divisible, consist of protons, electrons, and neutrons. Atoms of the same element are alike in all respects. Atoms of same element may not be alike as it is seen in isotopes. What are isotopes? We'll discuss little later in the same presentation. Moving ahead to the next, what is an atom? Now, atom, subatomic particles, you should know that atom consists of two parts. One is nucleus, which contains protons and the neutrons. Together, the component of the nucleus is called nucleons. Okay, here you should remember that protons are positively charged particles and electrons and neutrons are neutral particles. So generally you have the nucleus, which is a positive nucleus, and electrons, being the negative charged particles, move around the nucleus in a fixed orbit, that is the extranuclear region or orbits or shells where the electrons move. So what is the component? You can see here is an example of an helium atom where the nucleus contains two protons and two neutrons, so making the molecular, that is making the atomic mass of helium as 4 amu, right? And electrons, the mass of electron is negligible, and there are two electrons moving around in the shell. So the first shell is the K shell, where there are two electrons possible, which moves around in the fixed orbit. Okay, this is what the helium atom is all about. Why are atoms electrically neutral? Now you know that atom contains protons, electrons and neutrons. Okay, so now protons are P for proton, P is positive. N for neutron, N is neutral. Do not get confused with N negative. Electrons are negative. Is that clear? So now you know that what are nucleons? Nucleons are protons plus neutrons, where proton is positive and neutrons do not have any charge. So number of proton is exactly equal to the number of electrons. So now since the positive charges are equal to the negative charges, overall charge on an atom is neutral. Okay, now when you see the structure, you know that every atom consists of a nucleus, which is positively charged, comprised of nucleons, which is proton and neutron, right? So proton and neutron. So where are electrons situated? Electrons move around on an imaginary orbit but on a fixed path, that is called shells or orbits. According to the arrangement of the shells, that is the first shell, the second shell, the third shell and the fourth shell. So shell 1 is generally K, L, that is shell 2 is L, shell 3 is M and shell 4 is N. So K, L, M, N are the different names given to the shells according to their number. The small n denotes the number of the shell. Okay, so as we move ahead, you'll come to know that how many electrons can be fitted into the respective shells. Okay, so how many electrons can be fitted into the respective shells? You know that the value of n, small n, is given, right? So the formula is 2n square, where n is the number of shells. So for k shell, where n is equal to 1, the 2 into 1 square, that is equal to 2. So 2 electrons can fit into the k shell. Then 2 into 2 to the power 2, that is 2 to the 4 to the 8. 8 electrons can fit into the L shell. Then 2 into 3 square, then 3 is a 9 to the 18. 18 electrons can fit into the M shells, and 2 into 4 to the power 2, that is 4 for the 16 to the 32. So 32 electrons can fit in the N shell. So if you remember this formula of 2n square, you can write the number of electrons which each shell can accommodate. In your exams, we are going to study about only 1 to 20 elements. So here you have to remember that K shell will accommodate 2, L will accommodate 8, M will also accommodate 8, and the extra electrons moves to the N shell. Okay, but when the capacity is asked, you have to write for M 18 electrons can be fitted into the K shell. Is that clear, everyone? Let us move ahead. If in case you have any doubt or query, put it in the comment section. Your query will be answered. Now moving to the next topic, that is discovery of cathode rays, basically the discovery of electrons. Before going into the details of cathode rays, you must be aware what are cations. We have studied in our previous classes what is cation, right? Cat has got pause. You know that cat has got pause. So cations are positively charged. There is no kind of confusion that should happen here. Cation is a positively charged ion, and an electrode towards whom the cation gets attracted to is cathode. So to attract positive charged particle, that is cations, the electrode should be negative. You know that, you know the universal rule, opposite charges attract. So to attract a positive charged cation, the cathode must be negative. I hope this much is clear. Now let us move ahead. He is William Crook on your in front of your screen. This fellow only worked with the experiments of cathode rays, and an electric discharge was passed through the tube containing a gas at low pressure. Blue rays were emitted from the cathode, and these blue rays were called the cathode rays because they were originating from a negative electrode, that is cathode, and they were moving towards the anode. So this is how the cathode rays were discovered, which finally led to the discovery of electrons. Because what are cathode rays made up of? They were made up of electrons. Is that clear? Moving to the next, that is how the electrons came into picture. This, after the study by William Crookes, J.J. Thomson made the same arrangement, and then he started to study the cathode rays. The rays that were developed from the cathode had kinetic energy, and it could cast shadow of the object in their path. He also showed that cathode rays were deflected by positively charged plate, showing the negative nature of the rays. Now, what is the conclusion of this experiment? According to J.J. Thomson, cathode rays consist of negative particles. These are called now electrons. All electrons are identical, and atoms of all type contain the same particle electrons. Since an atom is electrically neutral, it must contain some oppositely charged particles. So this led to the discovery of the positively charged particles. Now you can understand that how one discovery leads to the discovery of the other element. Now since everybody knew that atom is electrically neutral and there is something negative present in an atom, so they wanted to find out what are the things present which is making an atom electrically neutral. So they were actually searching for the positively charged particle. Discovery of protons. Goldstein in the year 1898 discovered positive rays that contains protons, and these positive rays were generated from anode side. Goldstein used a modified cathode ray tube with perforated cathode so that it can allow the positive rays to pass through. He observed a new type of rays were produced from the anode passing through the holes of the perforated cathode, and these were called anode ray. And what was the content of these anode rays? It was protons. So this is how the proton came into picture. The positive rays were affected by the electric and magnetic field, but in the direction opposite of the cathode rays, showing that it had opposite charges. Thus, the discovery of positive particles, protons, was initiated, and finally led to the formation of proton. Now, while this discovery was going on, while the discovery of proton and electron took place, then they were trying to find out the structure of the atom. So here Rutherford played a very important role because he discovered nucleus. In 1911, he studied the atomic model leading to the discovery of atomic nucleus. He has done a very famous experiment of alpha particle experiment with the gold foil. Rutherford projected alpha particles towards a thin gold foil, and he noticed that the most of the alpha particles went straight through the foil, but some deflected slightly and some by large angles. So these three statements are very important. Some alpha particles went straight through the foil. This showed that most of the foil was empty space. Some were deflected slightly and some by large angles. So he observed that the atom consists of relatively empty spaces with a concentrated positive mass in the center, which lead to the deflection of the alpha particles. The discovery of the central positive region is that was the atomic nucleus. This was the experiment. Now this was the alpha particle gun. You can see this is the circular detector, and this is how the gun was passed. You can see that most of the particles passed through the foil, but very few deflected. That showed, and you can see rarely the things are getting deflected. That showed that there is a positive center, but it is a very small size. Moving to the next is the discovery of neutrons. Now what happened, people have already found out electrons, and they also found out that the number of electron is equal to the number of proton because all atoms are electrically neutral. Now the problem is the mass. It was observed that the mass of an atom was almost double to the mass of proton present. Almost double. Okay, so now proton, you know that electron never contributed to the mass because it has negligible mass. Proton had the mass of 1 AMU, but the mass of the atom was always found almost double the mass of the proton. Then there was a thought that there must be something in the atom which is contributing to the mass but not to the charge. That means there is something neutral present in the atom which has mass almost equal to the proton, but it does not have any charge. Okay, so now what was the postulate of Chadwick's theory? He said that since electrons have negligible mass, the mass of an atom, that is atomic mass, should be equal to the atomic mass of the protons. However, in the case of helium, which has only 2 protons in its nucleus, the atomic mass was not equal to the mass of proton but was almost double to the mass of the proton. So it was not equal, it was almost double. That is, it had 2 protons but the mass was 4. It is therefore proved that the nucleus of an atom are present with some particles which have no charge but mass almost equal to the mass of the proton, and thus the discovery of neutron was initiated. Now the next point was, how are these atomic particles arranged? So Rutherford has already told about the nucleus, where the positive center is in the nucleus. So now the rotation of electrons around the nucleus had to be discovered. Now this was done in the year 1940 by Bohr, that is Niels Bohr. Location and mode of rotation of the electrons around the nucleus was found out by him. Now, what are the postulates? He said that electrons revolve around the nucleus in the fixed orbits called energy levels or shells. The energy levels 1, 2, 3 are represented by KLMN, we have already discussed, or N, where N is equal to 1, 2, 3 respectively. Electrons revolve around the nucleus in one or more of the energy levels, and this is how the atomic representation is. That is, you have a positive center which is having protons and neutrons. Together they are called nucleons, and the blue balls which you can see in the diagram on the figure is the electrons moving around the nucleus. This is as per the modern atomic theory. Now this is lithium atom. You can see protons 3, neutrons 4 and electrons 3. And how the arrangement of electron is done, it's easily visible. And I hope you understood the concept of atom and the atomic structure. Right? Moving to the number of electrons, we have already discussed about the formula which states that 2n square, where n is equal to the number of shell. For k, n is 1, l, n is 2, m, n is 3 and n, n is 4. Calculating the maximum capacity of k shell is 2, l shell is 8, m is 18 and n is 32. So now this is what the next topic all about is the periodic table. Now children, there are few things that you need to remember. This hydrogen is a naughty fellow. He does not follow the rule. Okay, hydrogen being a non-metal is sitting on the head of the alkali metals. Okay, this is alkali metals. Now how will you remember? There is mnemonics. You can make your own mnemonics. Leena ki rabdi sasti and free. It's a simple way of remembering the order. In the question in your exam is generally asked arrange in logical sequence or arrange the elements according to the, that is arrange the elements from top to bottom in a periodic table. So you must know the order. Okay, so you have to know this. That is alkali metals. That is Leena ki rabdi sasti and free. Then you have alkaline earth metals. Alkaline earth metals. Now when you talk about alkaline earth metals, it is beryllium, magnesium, calcium, strontium, barium and radium. Beta, mange, car, scooter, baprazi. You can make your own simple mnemonics which you can learn, right? Now these, that is the horizontal rows and vertical columns, that is your vertical groups and horizontal periods. So there are total 7 periods and there are 18 groups. You have to remember 1, 2, then directly we move to 13. We don't remember, it's not required to know the light blue color elements that is shown here. You must know what are these yellow, these are metalloids. Then you have to remember the halogen group, that is group 17, right? Fluorine, chlorine, bromine, iodine are the elements of group 17. Then you have the noble gases. So you must know the order of these elements. There is one very good videos that is available on YouTube, that is about Peter Weatherall. He sings songs related to the periodic table. So there you can find out very beautiful songs by which you can remember these elements in their order. Okay, hydrogen is a non-metal. Though it is placed on the alkali metals, it behaves as halogens and it behaves as alkali metals. So when we study about the reactions, you study it, then you'll understand. Okay, in your exams, we need the first 20 elements. Okay, Mendeleev gave the, he's Mendeleev, he gave the periodic table and you need to remember the first 20 elements with the atomic number and atomic masses. When you see any atomic number, generally it is seen that for any element with atomic number, even atomic number, okay, even atomic number, you can say magnesium or calcium, the proton is equal to the electron and neutron is directly, that is neutron is also equal to the number of proton. So all the three things are equal. So when you see the atomic masses, it is double. 12 ka 24, 20 ka 40, right? Then you have carbon, carbon ka 12, 6 ka 12. It's just the double of the atomic number, right? Then if you see the odd numbers, generally electron is equal to proton, but neutron is proton plus 1. You can see here aluminium 27, 13 plus 13, 26. So 26 plus 1, 27. So the neutron is, instead of 13, the neutron is 14. Similarly for phosphorus, you can see for 15 the neutron is 16, right? There is an exception to it, high Benargan. If you remember, high Benargan, these four do not follow the rules. You know that in your class also there must be 4 or 5 children who never follows the rule. So in the periodic table also there are 4 children who do not follow the rule. Hydrogen has the atomic number 1, but the mass number is also 1. So hydrogen is not following the rule. How we represent? We represent the element as A to Z. Atomic mass, atomic numbers. Atomic mass, atomic number. So hydrogen, instead of having an odd number, has a mass also equal, same, not 2. Similarly, Benargan. Benargan is beryllium. So if beryllium does not follow the rule, beryllium atomic mass is 9 and atomic number is 4. 4 is an even number. It is not following the rule. Nitrogen 7 and 14. It's an odd number and it's not following the rule. It's just double. Argon is a little bit more naughty. Instead of 18, it has atomic mass of 40. Not double, it is double plus 4. So again, these 4 are not following the rules. They do not follow the rules. No rules for them. Okay, if you remember this, you don't have to mark it up. It will be easy for you to relate. Moving to the next, atomic number. What is atomic number? Atomic number is number of protons in an atom of an element. Since the atoms are electrically neutral, number of proton is equal to number of electrons. So atomic number is number of electrons present in a neutral atom. When you are writing about the atomic number and you are mentioning the number of electrons, it's very important to mention the neutral atom. Because if an atom forms an ion, the number of electrons will change. Because what are ions? When an atom loses or gains electron, they form ions. So if you are talking about neutral atom, atomic number is equal to number of electrons. Otherwise, always mention the number of proton in an atom is the atomic number of an element. So Z is equal to P is equal to E in case of neutral atoms. What is mass number? Mass number is the nucleons present. So total number of protons and neutrons present in an atom is a mass number denoted by A. A is equal to P plus N, that is atomic mass is equal to number of protons plus number of neutrons. This is how you represent the atom. That is the symbol of an atom and A to Z. A is atomic mass and Z is atomic number. Now you know that A is N plus P and Z is P. So number of neutron can easily be calculated by atomic mass minus the atomic number, right? So this you remember. Moving to the next, atomic weight, that is relative atomic mass. Mass of an atom is determined by indirect method and it's very small, so we need to have different methods to calculate the atomic weight. They were taken in comparison to hydrogen or later carbon. So relative atomic mass is equal to the number of times an atom of an element is heavier than a mass of hydrogen, or you can say the number of times one atom of an element is heavier than 1/12 mass of an atom of a carbon. You know that carbon, atomic number 6, mass 12. So 1/12 is equal to 1 only, no? So you have to compare with carbon, or if you can say hydrogen. So comparative study you have to do, where you take the comparison to hydrogen or carbon, that is number of times one atom of an element is heavier than these atoms. Molecular weight, now atomic weight is for atoms. Molecular weight is for molecules. So relative molecular mass is equal to the number of times Same thing, that is in comparison to one atom of hydrogen. Number of times one molecule of a substance is heavier than 1/12 mass of an atom. For example, if I have to calculate like carbon dioxide ka molecular weight, so you should know how much carbon should weigh and how much 2 atoms of oxygen should weigh. So that is 12 plus 16 plus 16, that is coming to 44. So 44 is the atomic mass, that is molecular weight of carbon dioxide. Similarly, when you have to calculate the molecular weight of water, that is H plus O. So 1 plus 1 plus 16, that is 18 AMU, atomic mass unit. So 18. This is how you calculate the molecular weight. Moving to the next, electronic configuration. Now with the electronic configuration, elements are represented numerically by the number of electrons in their shells and the number of shells. You just have to remember that you have to write it in form of this K, L, M, N. How many electrons they can fit. So 2, 8, 8 and so on. That is right. Since we are doing only till 20 elements, the maximum N that we will get is 2. But whatever extra that you can write. So you should know what is the atomic number. Atomic number will tell you the number of proton, which is equal to number of electrons. Then you have to divide these electrons in this way. Now in this example is given as nitrogen. So atomic number of nitrogen is 7. That means nitrogen has got 7 electrons. Since first shell can have 2, so what is left? 5. So second shell will have 5. So electronic configuration of nitrogen is 2, 5. Similarly, when you talk about sodium atomic number is 11, mass number is 23. That's not needed for electronic configuration. So sodium has got 11 proton, which is having 11 electrons. So first shell will have 2, second will have 8, 8 plus 2, 10, plus 1, 11. So electronic configuration of sodium is 281. Moving to the next, you tell me what is the answer. Write the electronic configuration of the following elements. Calcium. So calcium atomic number is 20. So number of electrons it can have is 20. So how will you calculate? It is 2882. Sodium we have just seen 281, 11 electrons, so 2 plus 8, 10 plus 1, 11. Sodium has, then next is oxygen. Oxygen has got 8 electrons. So 2 plus 6. Similarly, chlorine has got 17 protons, so 17 electrons, 287. Silicon has got 14 and boron has got 5. This is how you write the electronic configuration of the elements. Moving to the next, the fast recap of whatever we have studied till now. The atomic number of an atom is number of protons in the nucleus. The atomic mass of an atom is number of protons and neutrons, that is together they are called nucleons. The number of protons is equal to the number of electrons. Electrons orbit the nucleus in the shells or the orbits. KLMN, you are aware of it. Each shell can carry only a set number of electrons, which follows the formula 2n square, where n is equal to 1 for K, 2 for L, 3 for M and 4 for N. Moving to the next, there is some important terms, that is first one is isotopes. As you can see that I have marked P with red so that you remember it. Okay, isotopes P, protons. If isotopes means the atoms which have same number of protons, that is they have same number of, that is same atomic number. Now for your reference, let me write the representation of an atom here. X is an atom, atomic mass A to Z. So this is atomic number and this is atomic mass. Okay. The example, uranium, atomic mass is 92 and atomic number is 235 and 239. So they differ in the atomic masses but not in atomic number. That is why they have the same symbol also. Right, you know that elements are arranged in the periodic table on the basis of their atomic numbers. So atomic numbers are same, mass numbers are different. One more example is chlorine. Chlorine, what is the atomic number of chlorine? 17. It exists in two isotopes, that is 35 and 37. Similarly, hydrogen. Hydrogen exists as three isotopes, hydrogen, deuterium and tritium. So they have mass as 1, deuterium has 2 and tritium has 3. So they are hydrogen ka isotopes. Moving to the next, isotones. Isotones, n number of neutrons. So in this case you find the difference. 36 minus 16 is how much? 20. So it has got 20 neutrons. Similarly, chlorine 37 and 17, it has got 20 neutrons. Potassium has got 20 neutrons. And even calcium has got 20 neutrons. So all these have same number of neutrons. So they are called isotones. Isobar, the same bar, that is ball of mass. Same bar, that is same mass. So argon and calcium both have atomic mass 40. So they are the isobars. They have the same weight. Isotopes of hydrogen, you can see it clearly, that is protium, deuterium and tritium. They have different mass numbers, means hydrogen does not have a neutron, but the isotope of hydrogen, that is deuterium, has got 1 neutron and tritium has got 2 neutrons. So these are the isotopes of hydrogen. Moving to the next, that is first 20 elements, you can see. It will take a screenshot if you want, or you can so you can refer it to the valency symbols, nature. You can easily refer to this slides. Okay, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Their atomic electronic configurations and their valencies. Electronic configurations plays a very important role to find out the valencies. You can see that number of electrons present in the valence shell determines how much electrons the atoms need to become stable by gaining a stable electronic configuration. For example, if you see here, let us see from here. Hydrogen has got electronic configuration as 1. So it has valency 1. Hydrogen can form both ions, hydride ion, that is H minus, and hydrogen ion, that is H plus. So it can either lose the electron or gain the electron to acquire a positive or a negative charge. Whenever an atom loses an electron, it acquires a positive charge because the protons become extra. You can, if you want to understand, like for example, sodium. Sodium has got 11 electrons and 11 protons. Sodium has electronic configuration 281. So if this electron is lost, so the electron becomes 10, but the proton is 11. So sodium acquires 1 positive charge because of 1 extra positive proton. Similarly, when you talk about chlorine, chlorine has got 17 electron and 17 proton, and it has electronic configuration of 287. 7, you have to make it 8 for stability. So it requires 1 electron to become stable. So once it acquires 1 electron, that is gain of electron is happening. It has got 18 electrons and 17 protons. 1 electron extra means chlorine acquires a negative charge. We will talk about the ion formation little later, maybe in the next video, to make you understand the concept easily. If you need this video, put it in the comment section. Yes. Moving to the next, here also you can see sodium, it has got 1 electron, lose this electron, valency is 1, forms a positive charged particle, sodium ion, Na+. Magnesium 2 electrons are lost. Magnesium 2 electrons are lost, so acquires a 2 positive charge, valency is 2. Aluminum 3, silicon, generally the one which has 4, they share and form compounds. Then phosphorus 5, so instead of losing 5, gaining 3 is easy. So 3. It is if you have the valence shell till 4, valency is 1, 2, 3, 4. But if you have valence shells more than 4, you have to minus it from 8. So 8 minus 5, 3. 8 minus 6, 2. 8 minus 7, 1. And 8 minus 8, 0. Potassium again has got 1, so valency 1, and calcium has got valency 2. This is how the electrons are arranged in the shells for every atom. You can take a screenshot for your reference. Please write the number of particles, that is number of protons and neutrons present in the nucleus. If you write the nucleus correctly, if you place the electron correctly, then only you get your marks for the arrangement or the atomic orbital structures, or you can say the atomic structures. Okay, so hydrogen, 1 proton, 0 neutron and 1 electron in the outermost orbit. Similarly, you can see that as you move along the periodic table, the K shell gets filled in helium. So helium is a noble gas. Okay, it's a noble gas because here K is full. You cannot accommodate more, that is, you cannot accommodate more than 2 electrons in the K orbitals. Again, for lithium, the third orbital starts getting filled, that is not, in case, the next one is lithium. Here the second orbital, that is L, starts getting filled. L has got 1 here, 2 here, 3, 4, 5, 6. Then you have 7 and finally 8. So in neon what happens? The L shell gets filled. L has got 8 electrons. L is filled. This is again a noble gas. Then after L, M starts getting filled up. M has got 1 here, 2 here. Then you have aluminium with 3, 4, 5 in phosphorus, 6 in sulfur, 7 in chlorine, and 8 in argon. So again here in argon, M shell has got 8 electrons. So argon is a noble gas. After that N shell starts filling. So potassium ke liye N shell has 1 and calcium N has got 2. If an atom contains 1, 2 or 3 electron in the outermost orbit, then it has a tendency to lose electrons and acquire a positive charge. They are called cations, and generally metal forms cation. If the number of valence shell is more than 4, that is 5, 6 and 7, then they have the tendency to gain electrons and form anions, that is negatively charged particles. Non-metal form anions. Those who have got 8, or you can say complete shells, like for helium K is complete, for neon L is complete, argon M is complete, they are noble gases. They do not participate in any chemical reaction because they have stable electronic configuration. Next question which can be asked here, why atoms form compounds? Because everything moves towards stability. So even elements want to be stable, atom wants to be stable. To acquire a stable electronic configuration, atom forms ions and participate in chemical reactions. So valency you have studied, valency you have understood. It's of an element is the combining capacity of an element. It's a combining capacity of an element equal to the number of electrons lost, gained or shared by an atom during a chemical reaction, or you can say measure of combining power of an element with other elements. If it is the hydrogen atoms you can have, because hydrogen is, what is the valency of hydrogen? 1. So let's see some examples. Now here you can see water. In water, oxygen can combine with 2 hydrogens. So valency of oxygen is 2. In ammonia, nitrogen can combine with 3 hydrogen atoms. The valency of nitrogen is 3. In methane, carbon can combine with 4 hydrogen atoms. The valency of carbon is 4. Understood? Some elements, some metals shows variable valencies, like copper, iron. So they have variable valencies. When metal shows 2 different valencies, then the higher valency suffix is ik and lower valency suffix is us. Example you'll understand. For example, iron has got 2 valencies, that is ferrous and ferric. Ferrous matlab Fe2 plus, that is lesser one. Okay, you can see here 2 plus, that is ferrous, and ferric is 3 plus. You don't want to write ferrous and ferric, you can write iron 2, or here you can write iron 3. Okay, example, Ferrous chloride can be written as iron 2 chloride, and ferric chloride can be written as iron 3 chloride. These all concepts are being touched in standard 7 also, but I hope the concept is clear. Copper again shows two valencies, 1 and 2, that is cuprous and cupric. Iron, ferrous and ferric. Mercury, that is mercurous and mercuric. Tin is stannous and stannic. Then there are some non-metals also which shows different valencies like nitrogen, phosphorus and sulfur. Then why atoms form compounds? We have already understood about this concept, that stable electronic configuration is that of our noble gases. So atoms of the other elements are unstable and their valence shell is incomplete. So in order to make their valence shell complete by gaining or losing electrons or by sharing electrons, they try to acquire a stable electronic configuration. So you can see here all the noble gases, helium, neon and argon, are completely filled with their last orbit, and sodium has got one extra. On losing that one extra, it acquires a stable electronic configuration of neon. Chlorine, on acquiring one electron, can gain the electronic configuration of argon, and oxygen, by acquiring 2 electrons, can gain the electronic configuration of neon. Formation of compounds. Combining atoms redistribute their electrons so that each combining atoms attains a stable electronic configuration of the nearest gas. This is achieved by the transfer of electrons. Now the process of formation of compound by completely transferring the electron is the formation of ionic bonds. Okay, by the formation of ionic bonds. So electronic configuration. The first one, sodium atom, you can see has the electronic configuration of 281. So it loses out one electron to get the nearest noble gas configuration of 28. Since it loses one electron, it acquires a positive charge. Chlorine has electronic configuration of 287. This extra electron can be gained by chlorine, and since chlorine gains one electron, it has a negative charge. Okay. So now this positive and negative attracts each other and they come together to form a ionic bond and form a salt, that is common salt, NaCl. Electrons donated by an atoms, you can see how the positive and the negatively charged particles are formed, that is formation of cations and anions. Generally metals, it forms cations, and non-metals forms anions. So metals have 1, 2 or 3 electrons in the outermost orbit, and metals donate or lose 1, 2, 3 electrons to become a cation, and once they are cation, they attain the nearest noble gas configuration. Now sodium ion, that means ion means 1 plus, that means it has only 10 electrons and 11 protons. So 10 electron is a characteristic feature of neon. So it has got the electronic configuration of neon. Similarly, magnesium, aluminium all loses electron to attain the noble gas configuration, that is neon noble gas configuration, and acquire 1, 2 and 3 charges respectively. Electrons accepted. Non-metals generally accept electrons because they have 5, 6 or 7 electrons. So once they have, like chlorine has got 7 electron, it accepts 1 electron and acquires the electronic configuration of the nearest noble gas, that is argon. Oxygen acquires electronic configuration of neon, and so that is nitrogen also acquires electronic configuration of neon. Okay, by gaining 1 electron, 2 electron and 3 electron respectively. So number of electrons they gain, that much charge they develop. Why? Because chlorine here now had got 18 electrons but 17 protons. So 1 electron extra. So minus 1. Oxygen has got 10 electrons but the number of proton is only 8. So 2 electrons extra. 2 electrons extra. So minus 2. Nitrogen has got 7 proton but 10 electron after it has gained electrons, so it has 3 electrons extra, so -3 charge. I hope this concept is clear. Moving to the next, that is by sharing. Now you can see here that oxygen has got 6 electrons in the outermost orbit. Oxygen has the electronic configuration of 2 and 6, that is valence shell has got 6 electrons. Now oxygen wants to have 8. It wants to have 2 more. If it gets 2 more electron, oxygen will be stable. Now when you talk about the 2 oxygen atoms, so both the oxygen atom, now oxygen atom has got 1, 2, 3, 4, 5, 6. Similarly, another oxygen atom also has got 1, 2, 3, 4, 5, 6. So now 6 requires 2, and this 6 also requires 2. So it has got the formation of 2 pairs. It has common 2 pairs. So you can write double bond. Number of pairs. One bond shows exchange, that is sharing of one pair. Okay, so it shares 2 pairs. So it has got 2 bonds. Now some other examples of, you can see here as for example hydrogen. Okay, now when you talk about hydrogen, hydrogen has got 1 electron, another hydrogen has also 1 electron. So this hydrogen can become stable by having 2 electrons in the outermost orbit, and similarly that is nearest noble gas configuration, that is helium. So they share 1 pair. So hydrogen forms H2 molecule, that is single bond. Nitrogen, if you talk about, it has got 1, 2, 3, 4, 5 valence shells, because atomic number of nitrogen is 7, 2, 5, that is 5 in the outermost shell. 5 plus 3 is 8. So 5 अपना और ये 3 दूसरे nitrogen atom का, it gets 8. Similarly, it also shares the next 3 with the next element, that is nitrogen. So nitrogen forms a diatomic compound N2. So you can see hydrogen with 1 bond, oxygen with 2, and nitrogen with 3. Moving to the next, you can see how ionic bonds are formed. An example is given to you. Any doubt, put it in the comment section, children. If you put your doubts in the comment section, I'll try to answer them and provide you separate notes for your questions. Happy learning, and thank you so much for patient listening. Like, share and subscribe to be updated.